Hello my scholars, you're welcome to my school YouTube channel. My name is Emmanuel. Today's video will be tackling JAMB CBT past question in chemistry for the year 2004. Please don't go anywhere, stick around and we'll be right back. You're welcome back to my school YouTube channel. In today's video, we'll be tackling question number 1 to question 25. Now let's get down to question number 1. When a solid substance disappears completely as a gas on heating, the substance is said to have undergone what? Which means that when the substance is heated, the solid substance is heated, it does not go to the liquid phase, it just moves to the what? To the gaseous state. We said that is what? Sublimation, which is option D. If to evaporation has to do with liquid that is heated that turns into gas, okay? But we are talking about solid substance turning into gas, okay? Transiting into gas. Distillation involves also liquid, okay? That is what? That is heated, okay? Through boiling and then heating and cooling, and then we have that condensation taking place. So that is liquid. So not also this option. This C says crystallization. Crystallization has to do with liquid that is what? That is turned to what? To solid substance, which has to do with what? With crystals, forming of crystals which are solids, okay? So which is not the option. This says sublimation. Sublimation is a substance, is a situation or is a process when a solid substance actually turns or transits into what? Into gaseous state when it is heated. Example of such, we have your iodine, okay? We have your camphor, okay? We have your air freshener. Those ones you put in the room, even without applying it, once you keep it there, you discover that it's solid. After some times, it turns into gas, into vapor. You cannot see it. It doesn't turn into, it doesn't melt, okay? And then that's what sublimation. The opposite of this, the reverse situation of gas changing to solid, is actually called deposition, okay? Solid to gas is what? Sublimation. Gas to what? Solid is what? Deposition. So the correct answer is option D, sublimation. Let's move on to question number 2. A chemical reaction is always associated with what? Don't forget, in chemical reaction, there's exchanges of, it's either we are having atom of an element combining to another atom of an element to form a product, okay? That product is actually said to be a new substance, okay? That is formed. It could be reversible, it could be irreversible, but a new substance eventually will be formed. Usually, in some cases, we could have the valencies exchanging, okay, to have a new product. So that product is actually referred to as a new substance. So every chemical reaction is always associated with a new substance. And this is an increase in the composition of one of the substance, though. If it is that, that would have been a synthesis reaction, kind of, okay? Option B says a change in the volume of the reactant. If you are looking for a change in the volume of the reactant, we'll be talking of Le Chatelain principle, what has to do with chemical equilibrium, okay? When an increase in that, but generally that is also a chemical reaction. It is involved by showing the option C says a change in the nature of the reactant. Those are factors that can affect the rate of a chemical reaction. Option D says the formation of new substance. So every chemical reaction will always be associated with what? Product that will be formed, and that product that's formed is what? Is new substance. So the formation of new substance. The correct answer is option D. Question number 3. If a solution contains 4.9 gram of tetraoxosulfate 6 acid, calculate the amount of copper 2 oxide that will react with it. We have copper as the 64, that's the atomic mass of copper. Oxygen is 16, sulfur is 32, and hydrogen is 1. So first, before calculating this, you have to write a balanced chemical what? Equation of the what? Of the reaction. So let's go up. So the reaction is actually between tetrasulfate 6 acid, which is H2SO4, with what? Copper 2 oxide. This is your copper 2 oxide, CuO. So by the time they react together, of course, we have this copper is positively charged, 2 positive. We come to knock off this one, so we have H2. So water is coming, hydrogen is coming here to react with oxygen to form water. So we are going to form H2O at this side. Then we are left with copper here, okay, with SO4. Okay, of course the valency remains because copper is 2 plus, SO4 is 2 minus. So 2 cancels 2. So that's what should be. So this reacts with this. So this is, let's see if the equation is balanced. Hydrogen is 2 here. Hydrogen is 2. Oxygen is 1. Oxygen is 1. SO4 sulfate is 1. Just 1. Copper is 1. 1. So the equation is balanced. So if you look at it, this is ratio 1, okay, is to 1. That's what the mole ratio of the reaction. Okay, now the question says if a solution contains 4.9 gram of tetraoxosulfate 6 acid, calculate the amount of copper 2 oxide that will react. This is the amount we want to react, but we're given the mass of this. Don't forget that we're given that the mass, okay, of this H2SO4 was actually 4.9 gram. Okay, so all we need to do now is that we need to calculate the amount of this, because we want to calculate what? The amount of this. Okay, but we can calculate the amount of this and relate it to this. Says the combining ratio, the ratio of the reaction is actually what? Ratio 1 is to what? Is to 1. So if the mass is given to be 4.9, so all we need is we need the molar mass also. Okay, let's say we have the molar mass of H2SO4, okay, is 98 gram. I'm not going to solve that. By now, I think we should be able to solve molar mass of H, but as benefit of that, let's just have it SO4, H2SO4, hydrogen is 1, okay, times 2, okay, plus sulfur is what? Is 32, is given there on the board, then plus oxygen is actually 16 multiplied by 4, okay, so this will be 2 plus 32 plus, that should be 64, okay, if you add that together, that's 34 plus this, that is 98, so that is 98 gram per mole. So the molar mass of H2SO4 is actually 98 gram per mole. So we can go ahead now to solve that amount. Number of mole, don't forget, is equal to mass over what? Molar mass. So that will be equal to the number of moles. We want to find that the mass is 4.9 we're given, so we have 4.9 divided by molar mass now is 98. Okay, so by the time you solve this, 4.8 divided by this, move this once, that's 49, they had 0, 49 can go in 98, that's 2 times, so 1 over 20, so that's going to give us 0.05 mole. Okay, yeah, 0.05 mole. So that's what the number of moles is. But don't forget that the ratio of the reaction is what? Ratio 1 is to 1. So if it's ratio 1 is to 1, 0.05 mole, we also react with what? 0.05 mole of copper oxide. So if 1 mole is this, then 0.05 mole will also be 0.5 mole. So this is the amount. But don't forget that number of moles is actually equal to what? Still mass over what? Molar mass, just like we have it here in solids. So now we have to find the amount. This is mole. If you look at the units in which the values were given, the answer, it's in gram. Okay, they were all given in gram. So which means even though we have to find the amount, we want to find the quantity of this that will react with this. So the quantity in this case now, the mass now is what we are finding, because that's the gram that the unit is in. So we want to find what this. So we know that this already is what? 0. Okay, I think we can just make this mass over 1, cross multiply, 1 times mass is mass, equals to number of moles times what? Molar mass of what? Of copper oxide, not this again. So we can calculate that molar mass of copper oxide. Copper is 64, it's given in the board where we have oxygen is 16, not 32. So by the time you had that, that is 0.617, that's 8. So that is 80. So we have this to be 80. So this is a number of moles of this is actually 0.05 multiplied by 80. By the time you multiply this together, 5 times 80, that should be 400. Okay, 0.1212. So we have 4. That is 4.0 gram. Okay, that is going to be the amount of copper oxide that will react with this. So let's look at our options now. 4.0. Let's move back to the screen. We have option A 0.8, option B is 4.0, and so the correct answer is option B, 4.0 gram. Now let's move on to question number 4. What volume of gas is evolved at STP, standard temperature pressure, if 2 grams of calcium trioxocarbonate 4 is added to a solution of hydrochloric acid? So which means the reaction, just like we just solved now, we have to write out a balanced chemical what? Equation for the reaction. Okay, so we have the volume of gas that is evolved at STP. So reaction is between calcium carbonate. So when calcium trioxocarbonate 4 actually react with an acid, usually HCl, of course a gas will be what? 4, which is what? CO2. So they want us to find what? The CO2. Let's write the chemical equation, the balanced one, so that we can know what to do. So this is your calcium carbonate, that's your limestone reacting with HCl. So we have we are going to have calcium chloride, okay, Cl2, okay, plus we have CO2, because this is a carbonate reacting with acid. CO2 was before, and then we have H2O. So let's see if the equation is balanced. Calcium is 1, chloride is 2 here, so it's 1 here, so we have 2 here, Then hydrogen is 2 here, oxygen I think is balanced now. Okay, so this is of course gaseous, this is liquid, this is aqueous, then we have aqueous here, then we have solid here. So if this reaction takes place, so which means is reaction ratio 1 is to, we are looking at the stoichiometry now, the balanced equation and the coefficient for balancing. Ratio 1 is to 2 is to 1 is to 1 is to 1. Okay, actually we were told to find the volume of gas that will evolve. This is the gas that will evolve. This is our area of concentration, but this is what we want to find, the unknown. So there must be a known that we use to solve that unknown. Okay, that is our equation. So let's look at what we're given. We're given that okay, at STP, if 2 grams of calcium triisocarbonate 4, okay, so which means we're given this. So we are going to use this to solve this. Okay, interestingly, both of them are in ratio 1 is to what? Is to 1. Okay, so it's easier. So whatever thing we get for number of moles, just like we just calculated, number of moles that we calculate here, we are going to bring that in. It's going to be the same because the combined ratio, the reaction, 1 mole of this reacting with this is going to give us 1 mole of gas also. So what do we do? So we have, just like we just solved, we're given that the mass, given mass to be of this to be what? 2 grams, okay? And then we know that molar mass of, or I know that molar mass of CaCO3 is 100 grams per mole. Please, by now I don't think I should be solving how to solve molar mass, okay? But let's just do it for those that might have this. So if you calculate calcium carbonate, the molar mass of that, calcium is 40 plus carbon is 12 plus oxygen is 16, okay, multiplied by, we have 3 moles of that, multiplied by 3, so that's going to give us, we have 40 plus 12 plus 16 times 3, that's 8, 1, 4, that's 48. Then we have, this is 52 plus that gives us 100 grams per mole. So which means that the molar mass of calcium carbonate, okay, limestone, is actually 100 grams. So now that we know that, we can say number of moles still remains mass over what? Molar mass, because this is what? Solid. Okay, so number of moles in solid is mass over molar mass. So we can say that mass was given to be 2 over molar mass is 100. So by the time we divide that should be 0.11. That's 0.2. 2 over 100. Yes, 0.02 mole is going to be the number of moles. Remember, if 1 mole of calcium carbonate gave 1 mole of CO2, then 0.02 mole we also give what? 0.02 mole, okay, of calcium. That's the number of moles of that. But remember, the question says what volume of gas is evolved. Now we are talking about volume of gas now, not mass. So we are not going to use this again. So in calculating the number of moles in gases, okay, we have a formula also for that. We use number of moles equals to mass over molar mass when we are calculating for solids, number of moles for solids. But when we are calculating number of moles in gases, we use number of moles equals to volume over molar volume. Look at it again. For gases, number of moles equals to volume over molar volume. This molar volume is actually a constant. Usually we say it is 22.4 dm3 because the molecular volume of all gases at STP, the molecular volume of all gas at STP is always equals to 22.4 dm cube or 22,400 cm cube, as the case may be. Okay, so let's move on now. We have to find what volume. So which means we want to actually find what? V, volume. We already know what the number of moles is to be 0.02. Okay, equal to volume over what is our molar volume? We said it is 22.4, okay, dm cube. We're given from the question dm cube. So volume now will be 0.02 multiplied by 22.4. So that will be equal to multiply that should give us 0.448. Yeah, let's see. That's 0.8. That's a 44. Yes, 0.448. Okay, that's what we have. But this is what? dm cube, because this is what we're given in dm cube. Since the options we're given were in cm cube, so all we just need to do, we can't leave this in dm cube, so we have to convert to what? cm cube. So how do we do that? We just multiply 0.448 by 1000. Okay, because 1000 cm cube weighs 1 dm cube or 1 liter. So that's going to give us 448 cm cube. So the volume of the gas that will be produced, okay, with 2 grams of calcium carbonate is going to be 448 cm cube. Let's move back to the screen so we can look at the options we have there. The only place we have 448 is actually in option C. So the correct answer is option C. Now let's move on to question number 5. According to Charles's law, the volume of a gas becomes zero at what? Don't forget what the Charles's law says. We've treated that in one of our video lessons in chemistry, so you can subscribe to that. We talked about gas laws, the kinetic theory of law. So the Charles's law actually deals with or talks about the volume of a given mass of gas, looking at the relationship between volume of the gas as well as the temperature. Okay, the volume of a given mass of gas is directly proportional to the temperature, provided that pressure remains constant. So volume is proportional to T. So by the time you do that, you have V1 over T1 equals to V2 over T2. So which means it has a relationship to what? To the absolute temperature. And when we talk about absolute temperature, we are looking at the negative 273 degrees Celsius. That is why whenever you are calculating or making any calculations that has to involve volume and temperature, okay, in degrees Celsius, we must convert it to what? To the standard temperature, which is what? 273. So you have 273 to the value in degrees Celsius to get what we have in Kelvin, because that is the standard unit for temperature. So we have that 273. So by the time you draw the graph, okay, by the time you draw that graph on this point, we have it coming this way, because this is actually on the y-axis. Okay, so you have it here, minus 273. Okay, degrees Celsius is what you have on this point, because this is the what? The negative side. Then you have it coming up this way. That's your y-axis, and this is so we have this. So the question is, according to Charles's law, the volume of a gas becomes zero at where? At this point where we have minus 273. So the option is what? Minus 273. The correct answer is option C. On to question 6. It is difficult to achieve an orderly arrangement of the molecules of a gas. Why? Because they have difficulty in what is assembled together. Before you can have orderliness, a kind of arrangement of gases, it means that the molecules are actually bound together, okay, like we have in solid substances, and that's why we can be able to say that solids have definite shape, they have definite masses, and then they also have definite volume, okay, but that is not the case with gases. The reason why it will be difficult to achieve an orderly arrangement is because of the high kinetic energy, okay, that they have with them. You can see the molecules of gases are always having random motion, colliding with themselves and then with the walls of the container. So they don't stay together. So it will be difficult because of that high kinetic energy. And that is why it is responsible for what we call the weak intermolecular forces. So if the molecular force, the distances between the molecules is very, very high, you see them, the distance is very wide because of the kinetic energy that the high kinetic energy which they have present in them, among them, it will be difficult to confine them together. So we cannot have them having that orderly arrangement. So the intermolecular attraction between them, force of attraction, is very, very, very low or very, very little. Let's look at the option we have no definite shape. What is responsible for that? It is because of the weak intermolecular forces that they have between them, the high kinetic energy that they have, okay, among them. So option B says have little force of attraction between them. Yes, that's correct. Option C says can collide with one another in the container. What is responsible for that? That is not why we cannot achieve orderly arrangement, okay? And option D says are too small in size. So among these options now, the correct answer is option B. They have little force of attraction between them. Now let's move on to question number 7. A given volume of methane diffuses in 20 seconds. How long will it take the same volume of sulfur peroxide to diffuse under the same conditions? How long? How long is talking about what? The time. Now there's difference between rate of diffusion of a gas and time of diffusion of a gas. There's relationship between them. Actually, we're talking about Graham's law of diffusion that is certain. And what does Graham's law of diffusion say? It states that the rate of diffusion of a gas is inversely proportional to the to the square root of the molar masses or molecular mass of that. I'll say that again. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the molar mass. Of course, it could be, we could have it also vapor density as the case may be. But in this case now, we're asked to find how long will it take the same volume of sulfur. Let's look at the board. Based on Graham's law, the rate of diffusion of a gas is inversely proportional to 1 over That's the reciprocal, okay, inversely proportional to the what? The square root of mass. So which means that at rate, if it is rate of one of the first gas, if we have two gases, rate of dilution of a gas and then rate of dilution of the second gas will be equal to, since it is inversely proportional, it means that the molar mass, okay, of 2 will come first because it's inversely proportional. So rate of 2 will come first, then we have molar mass of what? Of 1 coming, because you can see R1 is here, molar mass is here, R2 is here, this here, because it's inversely proportional. This is what you should do. But in this question, we're told that we should find how long. How long is talking about the timing, and there's a relationship between rate of diffusion of a gas and timing. Okay, so that ratio of diffusion is what? Inversely proportional to what? To time taken for that gas to what? To actually what? Diffuse. So rate of diffusion of a gas is inversely proportional to what? To the time taken. So, but we're asked to find the time taken. So if this is inversely proportional this way, we are talking about time now, not rate now, because inversely T1 over T2 will be equal to square root of. Now it's not going to be T2, it's not going to be M2, because this is what? Inversely proportional. But for this case now, since this is inversely proportional to this, so this is going to be what? M1 also over what? M2. Okay, I hope you got that. So we have two gases here, which are methane and sulfur dioxide. Okay, so sulfur dioxide, so you can say methane is actually time for methane. I can have CH4 here over time for what? For SO2, okay, will be equal to square root of the molar mass of, since we started with methane, so we have methane here, okay, all over molar mass of what? SO2. If you were asked to find the rate of diffusion of that gas, so it's going to be rate of CH4 over SO2 will be equal to square root of molar mass of, since you have SO2 here, this will be SO2 here also, the mass of this, inversely proportional. But because rate is directly proportional, it's inversely proportional to what? To the time taken, because they say we should find how long. So it's going to be this over this, which should be equal to this. We have CH4 here, so we have the mass of CH4 here also. So from the question, we're given that methane diffuses in 20 seconds. So time for methane to diffuse is actually seconds. So we're given T, time for methane is actually 20 seconds. Okay, then we can say the time for SO2 is what they ask us to find. Okay, how long is it going to take? Then we have the molar mass of methane will actually be, so let's calculate, CH4 is equal to, carbon is 12 plus hydrogen is 1 times 4. Okay, so this gives us what? That's 16. Okay, then let's look at molar mass of SO2. Okay, sulfur is SO2, you can have that here, SO2, sulfur dioxide. Sulfur is 32 plus oxygen is 16 times 2. We have 2 moles of that. So this is eventually going to be what? 64. So we can come on here and then we calculate. Let's put in the values we have here. Okay, so don't forget that we said it is T, time taken for methane to diffuse, and time taken for SO2 is equal to square root of molar mass of methane all over molar mass of SO2. So time for methane was given to be 20 seconds. Over time for this, we don't know, that's unknown, SO2 will be equal to square root of, what is the molar mass of methane? That's 16 over molar mass of this is actually what? 64. Okay, so we can have this to be 20 over time SO2 is equal to, whichever way you want to solve this, you can just, this can go here, or you can start to find square root of this 16 to be 2, 16, square root of 16 over square root of 64. Whichever way you want to solve, you can go on and on and on and on to solve. So that's going to be square root of 16 is actually 4 over square root of 64 is actually 8. So you can say 4 goes here 1, 4 goes here 2. So that is 20 over TSO2 will be equals to 1 over 2. So by the time you cross multiply, we have TSO2 times that, we have TSO2. Okay, then we have 20 times 2. So TSO2 gives us what? 40 seconds. So it's going to take 40 seconds for SO2 to diffuse what? In 20 seconds for this. The same time which this is going to what? To get what? Diffuse. A rate of diffusion of a gas is inversely proportional to the square root of the molar mass, provided that the temperature and pressure and under constant remains what? Constant. Let's move on to the screen now to see what we have there. We have 5 seconds, 20 seconds, 40 seconds, and 60 seconds. So the correct answer is option C. Question number 8. An electron can be added to a halogen atom to form a halide ion with what? Halide ion. Don't forget that halogens usually are group 7 elements, and so because they have 7 electrons in their outermost shell. So maybe it is fluorine, whether it is chlorine, whether it is bromine, iodine, and so on. Okay, astatine, as we may have it. So let's just take any of the halogens. Okay, let's take the first one. Okay, the most reactive electronegative. Not the most reactive non-metal, that's fluorine. So fluorine has what? Atomic number of 9, which is what? 2 and 7. Okay, so which means for the first shell it has 2 electrons. For the second shell, because we are talking about valence electron. Valence electron has to do with what? The electron in the what? Outermost shell. So we have 7 here. So for this one now to become halide ion, which means that it needs just 1 electron to be added up here. So by the time you had 1 electron here, so it becomes, the first shell is 2, the second shell becomes plus 1 becomes what? 8 here. So which means it now becomes fluoride ion, that is halide ion. So when it becomes halide ion, minus 1 means that it has taken or it has accepted an electron maybe from the fellow atom like fluorine, or from maybe a metal or a highly electropositive element to become F minus. So this is the valence electron. This electron is what? Outermost shell, that is 8. So it's going to have 8 valence electron for it to become what? Halide ion. So among the options we have here, 2, 3, 4, 7, and 8. So the correct answer is option D, 8 valence electrons. Question number 9. The shape of s orbitals is what? Is it spherical? Is it elliptical? Is it spiral? Is it circular? It's not circular, it's spherical. Of course, spherical and circular are not the same. It is spherical. It is spherical. The reason being that the wave function of that orbital actually depends on the distance, okay, not on the direction. So which means that when you are trying to find an electron, okay, it could take, and it is the same thing from any direction with which you are trying to find it. Okay, so the wave function is dependent on the distance but not on the direction. So if we have y here, we have x here, okay, we have y here, we have x here, and then we have, so we have z, okay, that's z here. So by the time you have tried to find this, you have this, let's say we have the whole of this, so it's going to be the same. Let's just see. Okay, trying to find an electron from all this is going to depend not on the distance, okay, but it's going to determine, so it's not going to be dependent on the direction, but it's dependent on what distance. So the wave function is dependent on the distance, so thereby leading to what? The formation of what is spherical shape. So the shape of s orbitals is usually spherical. The correct answer is option A. Do you know you can take practice questions on our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to download the Myschool mobile app for your Androids and the Myschool software for your laptops and computers. Please go ahead and start practicing. Now let's move on to question number 10. This is a nuclear reaction here, okay? We have Ra, that is radium, okay? And then this Rn, both of them, their name sounds alike. This is radium, R-A-D-I-U-M, and then this Rn is radon, okay, or radon, R-A-D-O-N. So we have 226, that is the atomic mass here, to be 88, and then the molar mass is actually 226, and then you have X here. So we're asked to find the value of X in the what? In the nuclear reaction that we have here above. When it is bombarded to what? Produce what? Alpha what? Particle. It undergoes radiation to give up what? Alpha particle. So let's look at the board to see. Okay, that is a radium. We have this here, we have this here. So to get this first, we need to get this. Don't forget that alpha particle has to do with what? The helium, what is the helium atom? So which means it is bombarded with helium, and helium usually has what? 4 here, okay, as the atomic mass, and then we have what? 2 here, okay, as the molar mass. So with this, by the time you add up this and this, okay, let me just write this down so that it's easier. X here, then we have 86 here, okay. So the atomic masses, which are here, number of protons added together, should give us this one here. Okay, so let's see, 86 plus 2 gives us 88. Then this plus this should also give us what? This. So here is already 4. Here is 226. So x plus 4 should give us 226. So we can say 226 should be equal to what? X plus what? Plus 4. The mass numbers, these ones that are up here, you had them. So which means x is equal to, you can say 226 now. Transfer it becomes minus 4 equal to x. So transfer that, we have 2, 2, 2. So which means the value of x is actually 2, 2, 2. So let's look at the options we have together. We have option A says 220, option B says 222 TT. So the correct answer is option B, 222. I believe you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video. Question number 11. The property of chlorine which causes hydrogen chloride to be more ionic, that means we're talking about electrovalent bonding, okay, than the chlorine molecules is, it's what? When we talk about chlorine forming what? Ionic bonding, to be more ionic than what? With the chlorine molecule, because chlorine molecules usually, we say they are what? They are covalent, because we have two atoms of chlorine, okay, combining together to form the chlorine molecule, okay, Cl2. So that is what? More of what? Covalent bonding, because it involves what? Sharing of what? Of electrons, okay, for the bonding to take place. But for this hydrogen chloride, that's HCl. Don't forget that hydrogen actually has a positive ion here, charge, and then chloride ion usually has negative here. So this has a valency of 1, okay, just as this. Why this one has electron activity of what? Electronegativity of what? 7. So now, because this one now needs just 1, and this one has 1 here, so this one can easily pull up this together with this one to get this, because based on, of course, this can also be molecule, because you can have this one can come and share one of the electron that it has here. It has one shell here, and then this one has 7 outside, so it can come together to share, so that this one becomes completely filled here, while this one also become what? 8 filled here. But in this case now, we are talking about what? Making it more ionic. Ionic bonding has to do with transfer of electron, not sharing like covalent. Ionic bonding is the bonding that is formed when what? There's transfer of electrons from the metals, usually to what? Non-metal. Even the hydrogen is not a metal, okay, but because it has a valence electron of +1, okay, which means 1 electron rich. So what makes it more? Because this man here, chlorine, actually needs what? Chlorine, because it formed chloride, it was already chlorine before. When it gains 1 electron, okay, accept, it becomes chloride ion here, okay. So what happens is, because it loves more electron, it wants to attract more electron to itself, and that phenomenon, when it undergoes chemical reaction, it wants to attract more electron to itself, and that is what we call electronegativity. The reason we say group 7 elements are the most electronegative elements in the periodic table, and that's why we have fluorine being the first on the group 7 element, the halogens being the most reactive what? Non-metal, okay, which is what we talk about the highest what? Electronegative element. So based on that, we talk about electronegativity. So which option? The option of positivity, we'll be talking about the group 1 elements. They are the most electropositive element because they are rich in the electron. They have valency of +1. Therefore, by the group, the alkali metals, okay, actually are the most, that the electron affinity has to do with the love of electron, okay, that they have. It looks similar to this, okay, but the difference, this one has to attract electron to itself, so that in the chemical reaction, and eventually it has electrovalency has to do with the valency of the electron. So among these options now, the property of chlorine which causes hydrogen chloride to be more ionic than the chlorine molecules is its what? Electronegativity. So the correct answer is option D. Let's move on to question number 12. Chlorine consisting of 2 isotopes of mass number 35 and 37 in the ratio 3:1 has an atomic mass of 35.5. Calculate the relative abundance of the isotopes of mass number 37. So to make it, there are different ways of solving this, but don't forget this is JAMB, and then you are working with time. How can you get your answer within the shortest period of time accurately, okay, with the shortest method you can use? So you can choose to begin to go through the explanation. Of course, if you look at the explanation that is given, okay, we have different methods, okay, that we use to solve it, but let's just look for the simplest approach. Okay, so all we need to do is the atomic mass. We just say that since the unit, the ratio is ratio 3:1, and then respectively. So 35. So which means that let's use the board. Yes, use the board. Which means we have 35 chlorine, okay, and then we have 37 chlorine. These are the two isotopes of what? Of chlorine, okay. Actually, it's going to give us, we have that. So, and how do we form this? We said we're given that ratio 3 is to 1, okay, which is 35 is 1, which is ratio 3 is to what? 1. All we need to do is what? We just have, this is, add these ratios together. By the time you add the two of them together, we have what? We have 4, okay. So, which means the ratio for this one is actually 3. For carbon 35 is 3/4, while the ratio for this carbon of chlorine 37, okay, is actually 1. So we have 1/4 also. So that's all. So all you need to do is just find the percentage of it. Then you are good to go. So of course this is 0.75. This is 0.25. So find the percentage, multiply by 100, multiply by 100. Okay, this is 25%, yes, 75. We actually asked for what? Abundance of what? Of 37 chlorine, the one that has mass number 37, which is this one, not this one. So the answer is just what? 25. Let's move on to the screen. We have option A, 20, 25, 60. So the correct answer is actually 25. Option B is the correct answer. Question number 13. Which of the following mixture of gases is likely to burn in flame? Option A says neon and hydrogen. Yes, neon and hydrogen make up, of course. Don't forget that neon is a noble gas, it's an inert gas, but when it combines with hydrogen, okay, it burns. Okay, it burns and then it gives off what? Flame. What happens in this case? Usually when both of them combine together, if they are lit, maybe in a flame, they begin to burn, and while they are burning, the atom that make up that gas will absorb energy. Okay, when it absorbs energy, it becomes excited. When it becomes excited, it moves to the what? Excited state. Okay, and then by the time it begins to cool down, it begins to what? Loses energy. It comes down. As it's coming down from the excited state to gas state, it begins to what? To emit energy, and then in form of what? In form of flame. So we have neon and hydrogen. Yes, they are a mixture of gases that actually is likely to burn in flame. Option B says nitrogen and helium. Of course, we know that nitrogen does not support burning. Okay, so that's not going to work, even though this is inert gas. Option C says we have helium and neon. Helium and neon are inflammable gases. Okay, inflammable when they are combined together. Okay, unlike when we have this one that are what? That are actually flammable, and then we have neon and nitrogen. So nitrogen will also make neon not to function because this does not support, even though we have a larger percentage of it in air, like 78%, but it does not support burning like we have in oxygen, nitrogen. So option D is also not correct. So among these options, the correct answer is option A, neon and hydrogen. Question number 14. Hardness of water is caused by the presence of ions of water. Remember, we know that hardness of water is caused when soap does not form water. Okay, the water does not form lather, okay, with soap. When you use soap, water to wash, okay, and then you use soap, it does not foam, it does not form lather, okay. We said that water is what hard, okay. What is responsible for that? It is possible, it is either the temporary hardness, or we have what? The primary hardness. We have the temporary hardness, or we have the permanent hardness of water. Either of the two could be. So, but for either cases, they are caused by what? Ions from calcium ions and what? Magnesium ions. So, if it is temporary hardness, we say we have calcium, hydrogen, triisosulfate 4, okay, and then we have magnesium hydrogen triisosulfate 4, okay, could actually cause the temporary hardness, which can be removed by ordinary boiling of the water. You have the thawing of the what? Of the ions around the what? The kettles or the boiling rings that we have. We have those ones that are formed there and roasting. But if it is permanent hardness, that cannot be easily removed by water. Okay, we need chemicals to do what? By boiling. We need chemicals to actually what? To remove that particular type of hardness. It could be caused by calcium tetrasulfate 6, CaSO4, and magnesium tetrasulfate 6. So that is it. But in that cases, they are caused by the presence of ions of calcium ion and what? Magnesium. So if we look at these options that we have here, we have calcium and sodium, no. We have sodium and potassium, no. We have calcium and magnesium, yes. Magnesium and silver, no. So the correct answer is option B, calcium and magnesium. Question number 15. Pollution of underground water by metal ions is very likely in the soil that has high what? Now, this question has two possible options that we might want to consider. We talk about acidity, and then we talk about nitrate content. Now, when we talk about nitrate content, okay, please listen very well. Nitrate content, all triisonitrate ions usually will dissolve in water, okay? So that might be one of the points we might be looking at. And then when we look at acidity, acidity has to do with metal ions, okay, that are dissolved, that are liberated eventually in the water, okay? So this also it is. But if you look at the two options critically that are similar, nitrate content usually, well, like I said earlier on, triisonitrate ions usually, all triisonitrates 5 ions usually will dissolve in water, okay? Yes, they can actually cause pollution also, but it is linked more with eutrophication, okay, and more of health issue than looking at them causing what? Pollution. It's because of the what? When you talk about eutrophication, we're talking about the point of that nitrogen that is formed. We have it forming, you know, on water substances. We have it that causes some of those plants, you know, that are on top of the water. You see them, those hydrophytes, and then you have them. So nitrate content can actually undergo, both of them, both nitrate content and acidity, actually have the tendency to have metal ions that are what? That are dissolved in the soil. But when we want to choose between the two, it is more of acidity. Don't forget that metal ions, when they react, okay, easily in the soil with the acidity of the soil, what happens? Of course, you can tell reaction between an acid and metals, okay, we give off hydrogen ions. Then we have the salt, the ions that are the metal ions that are being what? Dissolved in it, and they can migrate in the soil. So more of acidity it is than nitrate content, okay? So when we look at these options now, pollution of underground, because when the ions become dissolved, become soluble in the soil, in water, and then the soil, as they move in the water, what happens? They begin to lead to what? Pollution of the water, the underground water that we have in it. So it is more linked, okay, not with nitrate content, even though it is, but it is more with what? With acidity. So based on that, the pollution of underground water by metal ions is very likely in the soil that has high acidity level, okay, than nitrate content. So the correct answer is option A, acidity. Question number 16. A carcinogenic substance is, when we say carcinogenic substances are substances that can cause cancer, okay? Carcinogens, we call them carcinogens, okay? Carcinogenic substances, okay, we have asbestos dust, we have sawdust, we have nitrogen 2 oxide, carbon 2 oxide, we have asbestos dust, okay, are carcinogenic. Sawdust are also carcinogenic from the wood, okay? That's how you go to the sawmill, you have them using a stronger nose mask, face mask to cover so that it doesn't affect the lungs, and then it will cause cancer because of that. But asbestos, because of the material with which the asbestos dust is made up of, this is more carcinogenic, okay? Consider that sawdust, okay? So this one is highly reactive. The chemicals that make up this asbestos dust is highly reactive, that can lead to more of what? Causing cancer, that can affect the lung, the nostrils more than the sawdust. So based on that, the correct answer is option A, asbestos dust. Now let's move on to question 17. The solubility in mole per dm cube of 20 grams of copper sulfate dissolved in 100 grams of water at 180 degrees Celsius is what? There are different ways of killing a rat. You can go for the simplest one. Don't forget, we want to solve the question in the simplest method and then solve it accurately, and then with the shortest period of time, okay? So let's just move on to this solubility. Let's move on to what? To solve it using the direct formula. Let's move on to the board. We know that solubility is equal to the number of moles of solute, okay? Number of moles of solute multiplied by what? That is dissolved in 1 dm cube, okay? So, but 1 dm cube is usually what? 1000 cm cube. 1 dm cube is same as what? 1000 cm cube. So, divided by what? The volume of what? Of the solvent. Okay, we have solvent there. Don't forget that before we talk about solubility, we have solute dissolved in solvent to form solution, okay? How much of that solute will dissolve? That's why we have number of moles of solute that will dissolve in 1 dm cube of the what? Of the solvent. That's why we are having 1000 divided by this. So if you look at the question, we're given 20 gram, which is mass, okay, of that to 20 gram. Okay, that's all we're given. Then we're given the 100 gram of water. Water is our solvent there, so we can say volume of solvent is actually 100 gram, and then a temperature of that. So all we need to do now is what? We want to find this, but do we know what number of moles of solute is? No, but we can calculate. Don't forget, recall that number of moles actually is equal to what? Mass over what? Molar mass. So we can put in that in place of what? Number of moles. So we can say solubility is equal to, so instead of number of moles, if we are not given, we can say mass over molar mass times what? 1000 over what? Volume of the solvent. So this is, the mass is actually 220. Okay, we are given 20 gram over molar mass. So molar mass of copper sulfate, let's quickly calculate that. Molar mass of copper sulfate, copper sulfate is equal to, copper is actually 64, is given, plus sulfur is 32, plus oxygen is 16 times 4. Okay, and of course that is 64. So 64 plus 64, that gives us 128. 128 plus that gives us 10, 6, 6, 160. So this is equals to 160. So we just say 20 divided by 160 multiplied by 1000 all over. The volume of the solvent was given to be what? 100 grams. So we have 100 here. Okay, so let's see what we have. 0 cancels 0, 2 here, 1, 2 in 16, that's 8. Then we have 0, 0, 0, 0. So we have 1 times 2, that's 10 divided by 8, and that's 8. So 8 goes in 10, that should be 1. Okay, then we have points. We have this left, we have, that will be 2. Then we have it in that, that is what? That is in 40, that's 5. So 1.25 mole per dm cube should be what the solubility eventually will be. Let's move on to the screen and see what we have. We have 0.13, 0.25, 1.25 mole per dm cube. So the correct answer is option C, 1.25 mole per dm cube. Question number 18. Calcium tetrazosulfate 6 dissolves in water only sparingly to form a what? When a substance or calcium tetrasulfate 6 dissolves in what? In water sparingly, means that just little quantity was what was dissolved. The remaining one is the what? The solid that we have there. So we say we have formed precipitate, not suspension, precipitate. So calcium tetrazosulfate 6 dissolves in water only sparingly to form a precipitate, not solution. Yes, we know solution is solute plus solvent, okay, to form what? Solution. Okay, of course this can be your solute while the water is the solvent. That is generally for all solutions. Okay, but we are looking at type of solution. This one is now we have just little amount of the calcium tetrasulfate that is what? That is dissolved, while the other ones, the solid remains. So it is precipitate that is formed, not suspension, not colloid. Okay, so the correct answer is option C, precipitate. Question 19. Which of the following compounds is a normal salt? Normal salt. You know, we have different types of salt. First, we said a salt is a substance that is formed when all the hydrogen ion that is present in an acid is replaced by a metal ion or metallic ion or an ammonium ion. Okay, once you replace all of the hydrogen ion that is present in the formula of acid, let's say HCl, if you remove all the H, then you have a metallic ion coming in, like potassium coming to replace, like we have HCl here, this is an acid, HNO3, this is an acid, H2SO4, this is an acid. Okay, so if any metal, let's say metallic ion, this one Na plus, lithium ion, okay, any of this comes in to replace all this hydrogen, what we have is what we call salt. Okay, so or any of this one or other element, we can have magnesium ion, any metallic ion comes in, or ammonium ion comes in to replace all this hydrogen that's present in acid. What is formed is actually what we call a salt to a chemist. Okay, yes, we have different types of salt. We have the normal salt, we have the acidic salt, we have the basic salt, we have the complex salt, and we have the double salts. Okay, but normal salts, as the question says, are formed when we have all the hydrogen, okay, that is present being replaced by what? By a metallic ion or ammonium ion. If you look at all of these options, now option A says NaHS. So which means you still have hydrogen here. Because of this hydrogen that we have here, this is acidic. This cannot be a normal salt. Okay, we have NaHSO4. We have Na, yes, this is a metallic ion, but we still have hydrogen. So it is not all the hydrogen that were replaced. Okay, of course, if you look at this actually came from this H2SO4. Okay, so one sodium metal ion comes in here to replace one hydrogen here. So that's why we still have NaHS. So this is also acidic salt. Okay, we have NaHCO3. Yes, this is also coming from H2CO3. That's the acid, H2CO3. But because sodium is coming in, so it replaces one of this hydrogen here and displaces one. So we have NaH. So this is also acidic. But this one, yes, this is a basic salt, of course, because it is basic, because we have, of course, this is your washing soda, or what we call soda ash, Na2CO3, used in treatment of water and the like. It finds application. But if you look at this, Na2CO3, we don't have hydrogen here. We have Na2CO3, which means that, don't forget that salts actually came from what? From acid. So if we have CO3 here, which acid has CO3? It is this, H2SCO3. So which means there was initially hydrogen here, but sodium ion came in to replace this hydrogen ion, two of them, so to form Na2. So all the hydrogen ions that are present in the acid has been replaced. Though it's a weak acid, but it has been replaced to have this. So based on that, this one forms what? A normal acid. Just like you can have usually NaCl. NaCl came from HCl, okay, maybe and sodium hydroxide. So sodium came in to replace all this hydrogen ion to form NaCl, which is a normal salt also, just like this. So based on the analysis, the correct answer is option D. Do you have any question bothering your mind at all on all we have done so far? Please feel free to ask your question. All you need to do is to click the link in the description below that takes you to the Myschool website. There, you'll be able to ask your questions and solutions will be provided within the shortest period of time. Now, let's move on to the next question. Question number 20. What volume of 0.5 mole per dm cube H2SO4 will exactly neutralize 20 cm cube of 0.1 mole per dm cube sodium hydroxide solution? So we need to write out a balanced chemical equation. It's actually between H2SO4 and NaOH, sodium hydroxide. If you balance up, of course, this is a neutralization reaction. This is a strong acid reacting with a strong base. Okay, so we're going to have we have Na2SO4 reacting to get what? Water, H2O. This is your liquid, this is aqueous. Okay, we have aqueous, and then we have that. So if you have this, let's use balance. We have 2 of sodium here, sodium is here, we have 2 here, yeah, and then let's have 2 here. I think the equation should be balanced. So if you look at this ratio, this is ratio 1:2. Number of acid, moles of acid, Na, is equal to 1. Number of moles of base is actually equal to what? Equal to 2. Okay, so but we are given also what volume of 0.5 mole per dm cube H2SO4. What volume? So we say given, we already have this, so we're given what volume of acid will be formed. So that is unknown. If 0.5 mole per dm cube H2SO4, that means concentration of acid is given to be 0.5 mole per dm cube. Okay, and then we were given also volume of the base was given, which is sodium hydroxide, to be 20 cm cube. So we have 20 cm cube, and then we also have the concentration of the base, Cb, was also given to be 0.1 mole per dm cube. So with all of this one now, of course, we have NaNb with your stoichiometry, and then that we've just had, and then in your quantitative analysis, that's your volumetric analysis, using the formula, we have the relationship CaVa all over CbVb, of course, equal to Na, number of moles of acid, over number of moles of base. So what happens here, by the time you cross multiply, okay, we have CaVaNb equal to CbVb Na. We're actually told to find Va. So where we have Va is here, so that means we can divide both sides by Ca and Nb, okay, so that CaNb, so that we have Va left here. So Va will be equal to, so Cb, what is concentration of base? 0.1 multiplied by, because volume of base is 20, multiplied by number of moles of acid is 1, then all over Ca, concentration of acid is 0.5, then multiplied by number of moles of base is actually 2. So let's see, by the time we have, let's say this, we move this once, so that's 1 over 5. So 5 goes here, 1, 5 goes here, 10, 2 here, 1, 2 here, that is 5. So we have 5 here, yes, that is 1 over 5, yes, 5 here, 1, 5 here, sorry, 5 here, 1, 5 in 20, that is supposed to be 4, sorry, not 10. Okay, then 2 here, 1, 2 here, that is 2. So 1 times 2 times 2, that is 2.0 cm cube. So volume of acid will be used in what? 2.0 cm cube. Let's look at the screen. We have option A to be 2.0 cm cube. So that is our correct answer. The correct answer is option A, 2.0 cm cube. Do you have better steps or better explanations on all we have done so far? Please feel free to share with us. All you need to do is to go to the comment section, indicate the question number and the solution you wish to share with us. Question number 21. The oxidation state of chlorine in HClO4 is what? Is it -5, -1, +7, +1? Let's go to the board. We have oxidation state of chlorine, okay, in HClO4, okay? That's what we want to find of chlorine in this. So first, the rule says that what? The oxidation state of what? Of a compound in free state, okay? The bonded way in free state like this, no ion, is actually always equal to 0. So you equate this to be 0. So we know that hydrogen is actually, so I'll just want to say hydrogen plus, let's split them, chlorine plus O4 equal to 0. So hydrogen, we know that to be +1, okay? Plus Cl, that's what we want to find. Then we have plus oxygen, we know that to be -2. The valency is -2. So -2 multiplied by 4 will be equal to 0. So we have +1 plus Cl, plus times minus is minus, 2 times 4, we have 8 equal to 0. So we have Cl will be equal to, move that, that is +8, then -1. Cl is equal to +7. So the oxidation state of chlorine in HClO4 is actually +7. Let's move on to the screen and see what we have. We have -1, +7 is actually here. So the correct answer is option D, +7. Question number 22. We have zinc oxide, of course solid, reacting with carbon 2 oxide or carbon monoxide, okay, in gaseous state to form zinc with what? CO2 gas. So in that reaction above, zinc has been what? Okay, so if you look at, we have zinc from this point and then zinc at this side. That's our case study. Zinc had oxygen here, and then he does not have oxygen here. So which oxygen has been removed from zinc here to form this. That is one. That has to do with what? The definition for what? Reduction. Remember that oxidation has several, redox reaction has several what definitions. Oxidation could be addition of oxygen, and then oxidation could also be removal of hydrogen. While reduction is removal of oxygen and addition of hydrogen. So anyone can kill. It could also be that oxidation is what? Increase in oxidation number, okay, while reduction is what? Decrease in oxidation number. So for this case now, we already have oxygen here removed from this zinc here to form what? Zinc solid. So which means oxygen has been what? Has been removed from this zinc to further. So removal of oxygen is actually reduction, okay? So if you want to calculate the oxidation, that is one. If you want to calculate the oxidation state, you can still do that. Oxidation state of zinc here, this is -2 equal to 0. Transfer that, it becomes +2. So oxidation state of zinc here is +2. Oxidation state of zinc here, this is a full state, this is 0. So from +2 to 0, that is a reduction in oxidation state. So that is also what. So which means zinc has undergone what? Reduction. In other words, zinc has been reduced in this particular equation. Not oxidized, not displaced, not decomposed, not displaced, not oxidized, it is reduced. So the correct answer is option D, reduced. Now let's move on to question number 23. Which of the following acts as both reducing and oxidizing agent? If it can act as reducing and oxidizing agent, that means it should have tendency to be able to undergo oxidation and then tendency to be able to undergo what? Reduction. So among them we have option A, hydrogen. Well, hydrogen can be a reducing agent. Okay, we can have it, let's see, hydrogen, if the hydrogen gas, H2, okay, oxygen can be added to it, okay, to become okay. So we have SO2. So this cannot act as both reducing and oxidizing agent. Option B says SO2. SO2, sulfur 4 oxide, yes, can act as reducing agent. It has different ranges of oxidation state. Yes. So it should be, we can have it for -2, we can have +2 when sulfur is alone. Okay, it has a valency of -2 when it is with SO4. So we have +4, +6. Okay, we have ranges of oxidation state. So it can act as a reducing agent, okay, by making this to go to oxidation by oxidizing H2S, that's H2S. Hydrogen sulfide can become oxidized to sulfur. Yes. So it can act as a reducing agent. It can also act as an oxidizing agent by reducing ferric. Yes, by reducing ferric to ferrous. Yes, ferrous oxide. Yes, it can do that, though in the presence of acidified potassium permanganate, it can do that. So this SO2 can act as both reducing agent and also oxidizing agent based on the variable oxidation state that it has, ranging from -2 to +6. Okay, we have H2S, can also have that, but this cannot have. So apart from option B, okay, option A, C, D cannot act as reducing and oxidizing agent. So the correct answer actually is option B. SO2, sulfur 4 oxide, can act as both reducing agent and oxidizing agent. Option B is the correct answer. Question number 24. In the electrolysis of brine, that's also what sodium chloride solution. Okay, in the electrolysis of brine, the anode is usually what? It has to be a substance that is actually inert. Okay, that is not reactive, and that is none other apart from all of this one. The one that is inert, that will not react with the ions, actually is the what? Is carbon. Usually we refer to as graphite. Graphite is the one that is used for that. So of course, graphite, we know it's type of what? One of the allotropes of carbon. So it's either we have carbon here or we have graphite. So it is carbon that we have here. Not platinum, not copper, not zinc. For electrolysis of brine, we make use of what? Graphite. And graphite is a carbon. So the correct answer is option D. Now let's move on to question number 25. The mass of silver deposited when a current of 10 ampere is passed through a solution of silver salt for 4,830 seconds is what? We have silver having 108 as the mass. We have 1 Faraday is equal to 96,500 coulomb, and then per mole for that. So let's move on to the board to write. Before solving questions on electrolysis, please, you must be able to write the dissociation action first. We are talking about, okay, the reactivity. We have silver. Silver is that. What is the valency of silver? It's actually what? +1. That is positive. Okay. So this is going to gain 1 electron. Okay, because this is +1. So it will gain 1 electron to deal that to what? Silver metal. This is your solid. So the silver ion gains an electron to become a silver solid or silver metal. So which means we just have 1 electron here that was gained. So if 1 electron is gained, it means that 1 Faraday, okay, amount of electricity. Don't forget that in the Faraday's law of electrolysis, we look at the relationship between the mass, okay, and then the quantity of electricity. Mass of substance and the quantity of electricity. So mass M is what? Proportional to what? Quantity, okay, of electricity. So 1 Faraday, which is quantity of electricity, will, okay, if 1 Faraday, I think I like to say, if 1 Faraday, okay, if it were 2 electrons, let's say it is copper 2+, it would have been 2 electrons that would have been gained, so it becomes 2 Faraday. If it were aluminium, that is +3, which means 3 electrons will be gained, okay, it's going to be 3F, okay, so, but it's 1 electron, so 1 times that 1 Faraday. So 1 Faraday quantity of electron produces quantity and mass. 1 Faraday, that's the quantity, produces, what's the mass of what? Of silver. We're given to be 108. Produces 108 gram of silver, okay? 108 gram of silver. If 1 Faraday produces, okay, I say produces, sorry. produces 108 gram of silver. The question says the mass of silver deposited. So we want to calculate the mass of the silver that is deposited. So we now say how much of Faraday will produce. What is the mass? It's the mass we actually want to find, okay, of mass that will be deposited. So X of what? Silver that will be produced. So that means we should know what the value of the quantity of this electricity is actually, okay. But don't forget also that Q is equal to what? IT. If Q is equal to IT, quantity is equal to what? IT. So quantity, we're given I. From what we're given, we have the I is the current, which is 10, okay, times the time that it takes is actually what? 4830. So we can put that here. So which means here we have current times what? Times the time is going to take 4830 coulomb, okay, will produce X gram. Is the X we want to find, the mass of gram, because it says the mass of silver deposited will be this. So if 1 Faraday equal to this, then this will be the, but since this is in coulomb, so we must also convert this to be coulomb. Don't forget that 1 Faraday is equal to what? 96,500 coulomb. So in place of this one F, we replace it with 96,000. So we just say 96,500 coulomb gives what? 108 gram. Okay? Then 10 times 4830, if you multiply that, that is 48300 coulomb will give what? How many? X. So that's just all we are going to solve. So if you cross multiply that, we're going to have 96,500 is equal to 108 multiplied by 48300. So of course this one is this times X. So X equals to that. So we divide both sides by 96,500. Divide by 96,500. So we have X will be equal to, if you divide all of this, 0 cancels 0, 0, 0 cancels 0. So we are left with 108 times 483 divided by 96,500. So by the time you sum all of these ones, we have 108 times 483 over 965. So that will be 54. By the time you punch that on your calculator, we have 54.06 gram. Okay, that's what we're going to have. So the quantity or the mass of silver that will be deposited when the current of 10 ampere in 4,860,000 is produced is actually 54.06 gram. That is what the mass of silver that will be. Let's move to the screen and see what we have as the options. So we can select option A says we have 108.0. That's not it. Option B says 54.0. Of course, that is so close. Option C says 27.0 and option D says 13.5. So among these options now, the most appropriate, that is closest to what we had 54.06, but we have option B to be 54.0 grams. So we go for the option B, 54.0 gram. The correct answer is option B. I believe you enjoyed this content because I really did solving those questions. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.